We are closer to artificial general intelligence now than ever before, thanks to foundation models such as GPT-3, Palm, and Llama. The problem is, these models have billions of parameters requiring a dedicated GPU infrastructure to perform hundreds of billions of mathematical operations per sample during training, fine-tuning, and inference. This infrastructure can be very expensive to set up and run. Is there any other way? At ThirdAI, we have been working on an ML library that can train and fine-tune LLMs with billions of parameters entirely on CPUs, and even on edge devices like laptops. We were able to achieve this through one core observation. While the recent advances in machine learning can be attributed to the increasing number of model parameters, we found that more than 99.9% of computations in LLMs have minimal impact on the output of the model. This result, published in ICML 2023, highlights how wasteful it is to use all of an LLM's parameters all the time. In fact, if we look at how our brains work, evolution seems to have arrived at the same conclusion, since only a small number of neurons are active at any given point in time. Inspired by this, we have designed a smarter ML engine that, for any given input, figures out which parameters are relevant and performs computations only on those parameters. We call this technology dynamic sparsity, and it can make neural networks up to 100 or even 1,000 times more efficient. Built on years of research, there are dozens of papers on this technology by our founders and team members in conferences like ICML, NeurIPS, and MLSys. With our tech stack, you can run ML tasks on commodity CPUs without any drop in accuracy or conversion speed, something that was widely considered to be impossible. Moreover, since dynamic sparsity makes our engine efficient enough to run on edge devices, you can even train models on your laptop. On top of our engine, we have built an AI ecosystem that can run entirely on commodity CPUs and integrates into any Python environment in a matter of minutes. Since our library is highly performant and easy to use on both cloud infrastructure and local machines, you can train the models on a large corpus on a CPU cluster in the cloud and then download that same model to fine-tune it on your local machine. This is a game changer in accessibility and affordability. To illustrate, let's say you are Costco. You have a catalog of 10 million products and you want to make product search easier for your store managers. Since each store has a slightly different set of products and inventories, a true store-specific product search engine requires a different model for each store. Hence, you'll resort to training and deploying multiple store-specific product search models, which makes training and inference costs very expensive if you use a GPU infrastructure as required by contemporary frameworks. To showcase how we can tackle this problem with our tech stack, we trained a product search model on a popular product search dataset called Amazon 3 million catalog. We trained the model on a CPU cluster with 5 CPUs and 200 cores in total. The number of tokens in the dataset is 350 million. Here you can see a ray dashboard for the CPU cluster while the model was being trained. Despite being a fairly large dataset and the model having roughly 2 billion parameters, the total training time was less than 12 hours. And the same trained model can be brought over from the cloud to an edge device. We will show you how you can load the model on your laptop and fine-tune it locally. In this demo, we'll look at Pocket LLM, a desktop app that uses a large language model for semantic search. The large language model can be trained from scratch on this app, running on a laptop, or you can download a pre-trained model from what we call the Model Bazaar. It's a hub where people can upload, exchange, or even trade specialized AI models. To demonstrate its capabilities, we will download a model that was pre-trained on Amazon 3 million catalog. We'll start with our first query. We search for a machine that can carry, so something portable, that can be used to wash our clothes. As you can see, the results are spectacular, as is the case with most other queries you throw at it. If you want to, we also have an integration with OpenAI to give you more of a conversational experience, but it's completely optional. In fact, if you choose not to use it, you will have an air-gapped system. Your data won't go anywhere. Let's move on to our second example, where we look for a product to remove lint and hair as well as to clean clothes. While the top results are decent, it may not be exactly what you want. So you can keep scrolling and retrieve more results with this button, and once you find the perfect result, you can upvote it. Your feedback is then used to update the model to suit your preference instantly. You'll see what I mean when I resubmit the query. This result now appears at the top. Next, we'll look at a difficult query. A human would know that a container which preserves temperature refers to something like a thermos. This time, the model doesn't seem to understand that. But then again, Amazon doesn't either. The difference is, on Pocket LLM, we can teach the model to associate two concepts with each other and update our LLM in an instant. Upon resubmitting the query, you'll see that the model has learned to predict the relevant results. And once again, we can use the upvote feature to improve the search results even more. Finally, what if instead of improving search results on existing products, you actually want to add new products to the search engine? All you need to do is to click this button to add the file containing the new catalog and train it. When we search for Fashion Diva white shoes for party, which is a product from the new file that we just added, we get exactly what we need. Just like that, a shop owner or branch manager can add new things to the search engine from their laptop. You just watched a demonstration of capabilities that are exclusively offered by ThirdAI. First, we trained an LLM on a cluster of CPUs, drastically reducing training costs as CPUs are almost 10 times cheaper than GPUs. Second, the model was trained on a CPU cluster that can be ported to and hosted on edge devices with a click of a button, making hosting costs negligible. Third, you can provide the model with human feedback and it improves instantly. Fourth, it is incredibly easy to customize the model by fine-tuning on new data on your local device. Last, and perhaps the best part, the entire system is air-gapped. Your queries, your feedback, and your data stays on your machine, guaranteeing privacy and security like no other.